Hello, and thank you for joining me in this session. My name is Aditya Krishnan, and I am the Product Manager for Steel at ALLPLAN. Before we begin, I would like to share a quote that has personally resonated with me over the years and given me a lot of pride in my work and our industry. Scientists study the world as it is, but engineers create the world that has never been. We choose to imagine a better world than the one we have today and use our collective skills to bring that vision to reality. Having spent the last decade as a structural and software engineer myself, I have never been more excited to be a part of the digital transformation that our industry is undergoing. It is my team's mission to make ALLPLAN AEC the best-in-class solution for multi-material and multidisciplinary projects. By delivering steel workflows to empower you, our valued customers, to take intelligent, data-driven decisions in some of the earliest stages of the project lifecycle. Over the next few minutes, we'll delve into some of the key factors that specifically impact the AEC steel industry and how design processes are being adapted accordingly. We'll then talk about how ALLPLAN AEC is rising to meet these challenges head-on now and in the future. Let's dig into some industry trends. The uncertainty in the global, economic, energy, and geopolitical landscape has resulted in rising material production costs, higher interest rates, and supply chain disruptions, all of which have directly affected construction output in 2023. However, the overall resilience of the steel industry, as well as strong advocacy by professional organizations, coupled with government stimulus through policies and spending, has driven EUROFER, the European Steel Association, to forecast a gradual recovery heading into 2025. The American Institute of Steel Construction, or AISC, has predicted an even earlier recovery due to an already observed increase in non-residential spending, especially for data centers and manufacturing. One can thus predict an increased demand for construction projects heading into 2025. Another important factor to consider is the skilled labor shortage that has been a perennial problem for the construction industry. According to several reputed sources, 88% of US construction firms currently have difficulty in filing positions across the country. ADP, a human resources platform provider, suggests that 41% of construction workers in the US are expected to retire by 2031. Post-Brexit, worker shortages of EU and non-EU origin are in the thousands, and an estimated 1.26 million additional jobs are needed to replace an aging workforce in the EU between 2023 and 2030. We have no choice but to educate and train a new workforce and automate workflows to compensate for the loss of the current generation's invaluable knowledge and experience. Environmental impact is another major driving factor behind decisions in upcoming projects. The World Green Council envisions that by 2030, all new buildings, infrastructure, and renovations will be required to have at least 40% less embodied carbon with significant upfront carbon reduction, and all new buildings must achieve net zero operational carbon. By 2050, new projects will be required to achieve net zero embodied carbon, and all buildings, including existing ones, must reach net zero operational carbon. Similar goals have been proposed by the US-based SC 2050 program. The fact that steel is almost 100% recyclable and 96% recoverable makes it an attractive material for sustainable construction. It comes as no surprise that these indicators are pushing project teams to mitigate risk by moving lifecycle assessment and optioneering, or the study of aesthetic, structural, and functional alternatives, to the earliest stages of planning and design development, where the cost of making such changes is the cheapest and the potential to reduce carbon impact is the highest. Architects, engineers, GCs, and planners are collaborating with each other earlier than ever before to arrive at an optimal design and structural system while still meeting their clients' expectations. Specific to steel structures, SE 2050 advocates for the early involvement of steel fabricators because it helps with the assessment of the relative trade-offs of these design decisions to optimize material usage and reduce waste, ultimately reducing environmental impact. Let's dig into these tools to see how ALLPLAN empowers you to intuitively, efficiently, and accurately model steel structures and connections in a true multi-material environment. During the early stages of design development, parametric design is becoming increasingly important for architects and engineers to develop structural systems to support conceptual forms while accommodating repetitive changes. This is a tough balancing act that can be extremely complicated. ALLPLAN AEC's powerful built-in visual scripting tool requires no external plugins or coding experience. Just bring your imagination. In this example, we've used simple geometric elements to develop a tunnel-shaped surface and have generated a supporting 3D space frame in a matter of minutes. The use of parametric modeling allows you to rapidly automate repetitive work, explore variations, while creating highly accurate and connected models essential for later stages of design. During the design development and subsequent phases of pre-construction, it is important to provide precise geometry, orientation, and quantities for a building's structural system. ALLPLAN AEC's structural framing elements use the Nemetschek profile catalog available via BIM+, ensuring accurate representation of elements across Nemetschek's product portfolio. An axis grid lets you quickly and accurately place structural framing elements, making it easy to create a connected model, which is essential for communication with engineers, detailers, and fabricators. It is possible to use floor levels, reference points, and planes to quickly generate roof frames. In this theoretical example, let's say the architect provides the interior roof line. We could use the bottom of steel as reference to develop the actual rafters. When modeling against reference planes, structural framing elements automatically adjust to plane modification, saving you valuable production time when changes are requested. You can use element endpoints to input the structure or numeric entry to setback elements to the faces of their support. This is unnecessary if you intend to automatically model steel connections, which is the next topic for our discussion. Depending on your project delivery method and the region of the world, an engineer might need to completely design connections themselves. They might delegate connection selection to a drafter or a detailer, or they might completely delegate design to a fabricator who engages the services of a connection engineer downstream. Particularly in the first scenario, modeling typical steel connections can be slow and error-prone. Custom connections for architecturally exposed structural steel might require aesthetic oversight from architects or their clients. Even with the right per-connection specifications, extra care must be taken to ensure that connections are buildable and erectable on the construction site. Not considering these factors early in the design process can result in change orders and RFIs, which wastes time and money for all involved. At the time of bidding, general contractors and planners are forced to pad their estimates due to the uncertainty around material wastage and fabricator-related labor. ALLPLAN AEC directly addresses these pain points by providing a collection of built-in tools to model by-the-book connections as well as custom connections depending on your usage scenario. The new automated connections tool gives you the ability to model realistic connections for an entire structure with a few simple clicks. It is powered by an intuitive connection modeling engine developed by SDS2, the industry leader in fabricator-ready connection design. Simply start the tool and select the structural framing elements that need connections. Based on the element framing situation at each node, the tool intelligently develops connections that conform to Eurocode 3, while ensuring the buildability and erectability of both the elements and their connections. This unique technology accounts for clashes between all connections at a given node, which ensures early detection of problems and reuse of connection components such as bolts on end plates sharing a support or multi-point brace gusset plates. You can customize the connections to your specific needs with SDS2 adapting geometry around your constraints, while applying all the same checks at every step. Here is an example of modeling an end plate haunch connection. The connection toolbox lets you model custom connections from scratch. Here is an example of a hinge and pin connection built using the tool, illustrating the ability to use custom plate layouts. ALLPLAN AEC's Unified Views and Sections System, or UVS, allows you to generate custom sections and cuts and views. 2D drawings are also directly linked with the 3D environment. This allows you to visualize overall steel structural and connection fit relative to other parts and materials of the building, including reinforcement or wall finishes. Associative labels allow you to call out important information using attributes on both structural framing elements and connection elements. ALLPLAN's fully customizable report generation system uses attributes on structural framing elements to quickly generate bill of material reports. In this example, you can clearly see the difference in weight before and after the creation of connections, improving estimation for material wastage, embodied carbon, and other useful data. As shown with the drawings, connection elements have attributes that can be queried, and the total quantities of connection material can be estimated in a very similar way. These reports can help you as a general contractor or a planner to estimate labor early, thus accelerating and increasing the accuracy of every bid. To aid with the communication of aesthetics and concepts with architects and clients, ALLPLAN offers integrations with several visualization tools and renderers such as Cineware, Redshift, Twinmotion, and Lumion, in addition to its own built-in real-time implementation. Having fully modeled connections, even approximations, lets you play with finishes, perform light studies, and so much more. Here is an example using Twinmotion Direct Link, touring the result of our multi-material journey. With its intuitive modeling tools, integrated connection modeling, and powerful drawing, reporting, and visualization features, ALLPLAN AEC can help you deliver high-quality steel models, streamline your workflows, and improve collaboration, especially in the earliest stages of the project delivery process. So what's next for ALLPLAN? Within ALLPLAN AEC, our goal is to accelerate your multi-material and multidisciplinary workflows through improvements and automation to achieve early design coherence with your clients and partners. We will ensure that change management for the few remaining RFIs will be quick and efficient through object associativity. This is just the foundation for the next generation of advanced steel capabilities within ALLPLAN and its product portfolio, and the future feels incredibly exciting to me. The recently announced strategic merger of Frilo and SIA into the ALLPLAN product family will revolutionize and accelerate steel production workflows across the project delivery process, paving the way for some truly exciting opportunities in data-driven multi-material design and prefabrication. At the Nemetschek Group, our collective goal is to ensure seamless interoperability between the solutions, leveraging expertise across the brands to achieve open BIM-based collaborative workflows across the architecture, structural engineering, detailing, and prefabrication disciplines. Ultimately, our goal is to empower you to shape the future by adapting to uncertainty and mitigating risk as early as possible, while sustainably paving the way toward a better built environment. I hope this presentation has shed some light on the challenges and opportunities facing the AEC steel industry and how ALLPLAN can be your partner in navigating this complex landscape. I encourage you to take a closer look at ALLPLAN and its various products to help you achieve smooth delivery of your projects from design to build. Don't hesitate to reach out to our team if you have any questions. We're always happy to help. Thank you.